Okay, so I will go ahead and get started, and I would very much appreciate it if y'all have any questions to please bring them up so that I can answer them and it's be that hopefully it'd be of use to other people as well. So if you have any questions, please holler them out or put them in the chat. But I probably won't see them in the chat, so hollering them out is probably better. So this is my plan of what I'm going to do is I'd like to go through the lab that y'all are going to do and explain some of the parts of it, and also explain some of the background parts as well as some of the parts that are specific to this lab, and then answer any questions that you might have about it. So I'm going to start by just going to the lab instructions themselves. And his instructions are always very detailed, which is good because you have all the information that you need. Sometimes it can be a little intimidating to make sure that you have all, that you know what it is that you're supposed to do. So by the time we're done, we should make sure that we do understand. Well, by the time you're done with the lab, you need to make sure you understand active high, active low controls, the Verilog for vector signals, always block and case statement, and the 7-segment display. And you'll be using the 7-segment display later on. And all the stuff you do in this lab tomorrow, you will be using later in the lab, later in the semester, if it's at all like previous semesters. So, for this particular lab, as well as for many of the labs, you don't have to use Vivado to make the files that you bring in with you. You can do them on any computer. It's best if you do them just as a text file. If you try to use a word processor, it'll put extra stuff in there that you don't need. So you want to make sure you save it as a text file. Later on, it would be best, if at all possible, for you to be able to have Vivado on your own computer, or I saw the email today that he's got it available on the lab computer, so that's really good. So that will be helpful. That has not been the case in the past. So, okay. So the first concept is vector signals. So could I get any indication as to whether or not y'all have seen vectored signals before?
I think we saw vectors in like we had to take C++ or
Mm-hmm.
computer science and C++
Right.
before that.
Right.
So they've
Right.
been touched on, but he didn't really go over them much in class, I don't think.
Okay. All right. So it used to be the case that you did not have to take the C++ class before you took digital logic. So I'm really glad they changed that because that made it's made a big difference. But so the vectored signals are very similar to what you would see in C++, but they're not entirely the same. So it is useful. Whatever you know about arrays still holds, but it is slightly different. So I'm going to talk about how it is different. So let me get here. Okay, so when you have there's several ways to think about why you might want to have a vectored signal. So one thing is it's like an array. You can use one name and have multiple uh, instances. It's not really instances, but if I had I'm looking at my cat who's sitting here on the table. If I wanted to have a variable for some reason for cat age, and I have 3 cats, I could have the vector cat age 2 to 0, and that would be okay. Well, now I've got 3 cat ages here. I've got available to me now cat age 2, cat age 1, and cat age 0. And I can access all of these independently if I want to. So I can treat each of those as an independent variable if I wanted to, but I can also access them all together as one variable. And this makes it different from probably what you did in C++. You can still do this in C++, but you can also think about a vectored signal, the way I have them set up here, these variables are just one bit like our variables have been before. So x, for instance, is either 0 or 1, x equals 0 or x equals 1. Those are the only two possibilities for it. And so you can think of a vectored signal as being a variable that is a certain number of bits wide. So I could say that if I had this cat age variable right here, I could say in my cat's, if these are just a bit, I don't know what cat age means. 1, they're alive, and 0, they're not. I don't know. I could make them wider than that if I wanted to. But so I can think of something like that it goes, the index that goes from 2 to 0 as being 3 bits wide. So I could use it to store a 3-bit number if I wanted to. So I could also say, rather than each one of these representing a cat age of 1 or 0, I could have this represent my cat's age as a binary number that was 3 bits wide. So 1, 0, 1. And so this would be, tell me that my cat's age was 1, 2, 4, was that 5? Yeah, so my cat is 5 years old, and I could access each one of these individually. I can also access it all together as the number 5. So I can do that. Now, so what I have here, my examples that I have here, are examples that are going to be similar, if not the same, for what you're going to use in your lab. So this first one that I have, input 10xy, what that is saying is x and y are both 2 bits wide. So x is a 2-bit variable, and y is also a 2-bit variable. And I could access the entire thing. I could say x equals and get the whole value, or I can access individually x0 and x1. So I can access the bits individually. AN is 4 bits wide because it has 0, 1, 2, 3, and seg is 7 bits wide. It goes 0, 1, 2, 3, 4, 5, 6. So we have that. But to use it, we will want to know how you can access or how you use numerical values in Verilog. So how do I actually get that binary number? So when you want to assign a binary number or a decimal number or a hexadecimal number, you have this syntax that you're going to use. So if I had, so this x could not be the x I have up there, because the x I have up there is only 2 bits wide. I do not think Verilog gives you an error if they're the wrong size. It just means that you've got some information that's cut off. But so this would be that I had assigned x at some point. So maybe I had said input x, and I could do this in different ways. I could say 1:4. I'll do that just for these purposes. Input, I'm sorry, I have that on the wrong side. It'd be input 1:4 x. So let's say that that's how I had assigned x. And then somewhere in my code, I have x equals this number right there. So what this syntax is, so I have 4 and then prime apostrophe. I don't know what it is. It's the it is the apostrophe. It's the thing to the right of the semicolon. B1010. So what this is saying is that if x, right, so I defined x as a vectored signal from 1 to 4, and actually, sorry, 4 to 1. Well, no, it doesn't. No, 1 to 4 is good because I wanted to show that what that means. So this number here says how many bits wide it is. So it's got 4 bits. 1, 2, 3, 4. This B says it's binary. So they're either going to be ones or zeros. You would use D for decimal and H for hexadecimal if you ever want to use that. And then I would have X equals this. Now, the reason these numbers, the 1 to 4, are important is it's telling us the individual indices of each of our numbers here. So if I have, this is from 1 to 4, then this means X1 is the first digit right there. X2 is the second one. X3 is the third one. And X4 is the fourth one. Now, I actually have a reason for bringing this up other than the fact that you need to know it for different things, but this particular variable right here, the one that you're going to use for your 7-segment display, Dr. Vady has made a very nice template file for your constraint file that has a lot of stuff already set up, and it's really helpful if you start at 0 rather than at 6. And I'll explain that when we... I'm sorry, if you start at 0 rather than at 1, and I'll explain it when we get to that part. Okay, so let me go back to this. Did I do it backwards? Zero, 3. No, I did not. Okay, so like if we look at the example we have here on the screen right here. So in this, I am sharing my screen, right?
Yes.
Yes.
Okay, good, because in the circuits, SI, I was carrying on for quite some time without sharing my screen. So in this example right here, we see that we've got X is defined from 3 to 0. So 3 to 0, which means our first digit here is X3. And then our second digit is X2, which is 0, and our third is X1, and our fourth is X0. So 3 to 0 means the one, it's going 3, 2, 1, 0, as opposed to if you did 0 to 3, then if you did 0 to 3, then X0 would be the first one, and then X1, and then X2, and then X3. There's not a right or wrong way to do it. It just depends on what is most useful for you in your situation. Okay. All right, so now let us go back to this and take a look at the questions I have there. I don't have, I'm not, they're only, it says X, Y, AN, and SEG are defined as above, but I only have questions about X. So I have 2 questions here that I'd like you to look at. If these are defined the way I have them up here, with what I have is input 1, 0, X, Y, semicolon. If X is, well, look, that doesn't make any sense. X would have to be 2B apostrophe 0, 1. Okay, so if X is 2B apostrophe 0, 1, what is x1 and what is x0. I want you to, I assume you have something to write with, write down what you think your answers to that are. And then if x is just the number 2, so I don't have a b in front of it or anything like that, I'm just saying the value of x is 2, then what is x1 and what is x0. So I want y'all to write down what you think your answers are to that, and then I'll give you a minute to think about it, and then we'll check those. All right, so our first one here, we have x is the 2-bit binary number 0, 1, and I defined x from 1 to 0, so x1 would be 0, and x0 would be 1, because the first number would be 1 and the second number would be 0. Okay, so now if x equals 2, well, x is x equals 2, but x is defined as a 2-bit binary number. Well, 2 is not a 2-bit binary number. 2 is a decimal number. Verilog knows what you mean, though. Verilog knows that you mean that if you put in 2 without the thing on it, it knows that you mean 2 as a decimal. And so it knows that you mean that x equals the binary number 2, which is 1, 0. So it knows that because that is the binary value for 2. And so then in that case, x1 would be 1 and x0 would be 0. So you've got that. All right. Now let's go back and take a look at the lab instructions. Actually, I'm going to pause for a second to see if there are any questions. So all that was just kind of Verilog background stuff on numbers and vectored signals. Are there questions on that before I go to the next topic?
So for the lab, in the lab it's labeled A, N, and C. It would go the smallest number to the biggest number then, if we're trying to set like.
So which I don't
Mhm.
remember if I did it backwards from how he did or not. But we are going to look specifically at the lab part. So do you remember
It's
where in the
in
lab you're
part
talking about? Oh,
3,
like
I
right here.
guess. I think.
Um, the problem to be solved. Okay, I see. Yeah. Okay. Um, so yeah, so he wants you to use the variable c. I use the variable seg because to me I liked that one. Yes. So he has it here that he wants you the way he has it lined up. He wants you.
Mhm.
He says here to do 1 to 7. He doesn't really
Okay.
care if you do 1 to 7. He doesn't care what you use whatever order you want. And I am going to recommend, and I'll go ahead and show why that you use something different. Let me show you why. Okay, when you should be very familiar with some of the stuff that's here in your lab resources folder in your Moodle page. So one thing that you have that's really nice is this constraints file template. And the constraints file template has in it, I don't have, let me get all of it. by the way, when you copy and paste stuff from the PDF to Vivado, be aware that sometimes there will be some formatting things that might not copy over correctly. So just if you get errors, strange errors, sometimes it's because a particular symbol might not have copied correctly, so you'll want to look for that. Okay, so in the constraints file, what the constraints file has are all of the different parts. Have y'all used the basis
We've
board
used
yet?
it a good bit last semester, and we started to use it this semester too.
Okay, so you have used it. All right. Okay, so the constraints file has all of the different inputs, all the different ports that you might possibly use on the basis board already set for you to go. You just have to put the right variables in to match whatever variables you put in your code. And so if you go to the segment display, right here, this is why I used seg, because it's already seg in here. And so the variable name is seg, and it starts with seg0 and goes up to seg6. And then there's also, the other one is the decimal point. I always put the decimal point in as well, because I've had times when I'm using the other segments that it just lights up the decimal point if I don't include it. So I always just put that one in and turn it off. And so rather than going from 1 to 7, I go from I actually go from 0 to 6 as I did in that example, or 0 to 7 if I include the decimal point. And then if I include the decimal point, I change the variable name for this last one to match. So it'd be seg 7. And the easiest thing to mess up and get errors that the error message you'll get won't tell you what it is. These brackets and the see, I did it wrong. The brackets and the curly brackets, if you get those messed up, it can give you an error. So this last one, I change that, and then I include that one as well. So anyway, I like to start with 0 because then it matches what's already in here, and I don't have to go in and change all the numbers. So and he doesn't care. So it says C1
So
to
around
C6 here,
seg,
but
I need to put
that's not
curly
relevant.
brackets like around the vector. Okay.
I actually don't know if you need to or not. I think you don't need to,
Okay.
but I always do because it was already there. But I think I've tried it without it, and I don't think you need them. Okay, so let's see. All right, now back to this. All right, so we're back here. Were there other questions? Okay, so now we're going to go on and talk about what you will need to have in your code to actually light up the segments. One thing that's very strange, and I don't know why the basis is set up this way, is that it really only wants you to have, if I'm remembering right, one display lit at a time. I think that is correct. And so you're going to learn a trick in a later lab to make it look like they're all lit up at a time. And so I don't well, I've never tried sending it a signal with more than one display on at a time. I might try that and see what happens. Okay, but so what you will do is you will send it a signal for AN, and that is also in your templates file. And AN is somewhere. oh, standard. So not the switches, not the LEDs, not the buttons. Maybe it's not, because it's not a physical switch or a light or anything. Um, yes, I have a million tabs. Yeah, I have it here. So, oh, maybe it was in the LED. Oh, here it is. Okay, I don't know why I didn't see it before. Yeah, it's right under. It's right underneath the 7-segment display is where you have the AN, and it is already named AN, and it's AN 0 to 3. So it's already set for you. When you get to the constraints file, what you'll have to do is you'll come through and you'll uncomment. So uncomment meaning take away the. In the olden days, we called these the pound symbol, hashtag symbol. You'll take away the ones that you need. So the ones that you're actually using, you'll take those away. And so for AN, all you'll have to do is uncomment these, and you will be good to go. So those, and then those are set because you actually are using the variable name AN. Okay, so the value of AN will tell you which display is selected. Now you'll notice that this is what is referred to as an active low control, and so the one that's on is the one that actually has the low signal. So 3, when 3 is low, that means display 3 is on. And the way the displays look are there's 4 displays here. So you have these. You have the 4 displays, the 7-segment displays, and the value of AN, which has the 4 bits to it, will say which one is on. Okay, so now there's that. Okay, so look at this example here. So it has output 3:0 AN. So that means it's starting with 3 and going to 0. And that's the way I would recommend that you do it, in that order, because that order matches this little chart right here, which is very handy to come back and look at. Or you can just remember which bit needs to be 0 to put it in. So this example right here, AN signal, and it's 1101, and you can see that if you were counting from the right, if the rightmost bit is 0, 0, 1, it would be display 1 that's on. And these are notice that the displays are numbered 0, starting with 0, because computers start counting with 0 and not with 1. So that is how you will tell the BASIS board which display you want to be using. Okay, there is also something called a parameter. And so a parameter is a value that you can define that you can then reuse without having to type it over and over again. And you can also give things a name that means something. So like, for example, here we have parameter uno. Uno equals 4B1101. Well, uno meaning one in Spanish, not using the number one because that might be confusing. What one are we talking about? But now, if you wanted to, rather than saying AN equals 4B1101, you could say AN equals uno. And that makes it easy for programmer to, if you put these parameters in, so you could put a parameter in later on that has the correct LED sequence for the number 8, for instance, and then you could just have a parameter named 8 or ocho or however you want to call it, and then you could just say equals 8 or ocho, and that makes it easy to read, easy for your program, easy to read your program. But you don't have to use parameters. You can also just use the numbers. So now we're going to look at the LED, and the LED actually, I'm going to stop and save what the recording, and then I'll come back and talk about the LED.